Today we'll be studying physical quantities in physics. Under this topic, we'll be considering the types of physical quantities, instruments of measurement, physical dimensions, and at the end of the day, we'll take some exercises and some questions will be given to you to take on for practice. Physical quantities are the quantities we study and measure in physics. Examples of physical quantities are mass, force, speed, pressure, etc. Types of physical quantities. There are two types of physical quantities. One, basic or fundamental quantities. Two, derived quantities, measuring instruments. These are instruments used to measure the value of physical quantities in the laboratory. The instruments include tape, stopwatch, vernier calipers, micrometer screw gauge, spring balance, etc. The use of some of the instruments for measurement is explained in the examples below. Physical dimensions. This shows the relationship of other physical quantities with mass, length or distance, and time. Physical dimensions is used to evaluate the correctness of a physical equation or formula. Example: the dimensions of mass, length, and time are capital M, capital L, and capital T, respectively. Example 1. Which of the units of the following physical quantities are derived? I, area. I, force. Number 3, mass. The fourth, pressure. The options are A, I, and the last option, IV. B, I, and IV. Option C, I, and I. Option D, I and IV only. The correct option is option B, because the quantities in option B are all derived quantities and their units are derived units. Option A and C have basic quantity and therefore basic unit in them and are incorrect. Option D is also not correct because a derived quantity, number 2, force, was omitted. Example 2. The diagram above represents a portion of a vernier calipers. What is its reading? The options are A, 7.37 centimeters, B, 7.73 centimeters. Option C, 8.10 centimeters. Option D, 8.32 centimeters. Solution. The men's scale reading, which is the mark or the graduation of the men's scale, or where the men's scale and the beginning of the vernier scale meet, gives a value of 7.0 centimeters. The vernier scale reading is the point where the vernier graduation aligns or coincides with a mark or graduation on the main scale. And the number that falls on that mark is number 7 on the vernier scale. So the vernier scale reading is 7 times the reading accuracy of the vernier calipers, which is 0.01 centimeters. Then by time 7 is multiplied by 0.01, we now have a value 0.07 centimeters as our vernier scale reading. The actual reading of the diagram above is therefore the summation of the main scale reading and the vernier scale reading, which is 7.37 centimeters. Therefore, the correct option is option A. Example 3. The diagram above represents a portion of the micrometer screw gauge. What is its reading? The options are A, 3.27 millimeters, B, 3.77 millimeters, C, 3.85 millimeters, D, 3.87 millimeters. Solution. The main scale reading, which is the last graduation on the linear main scale before the circular vernier scale, is 3.50 millimeters. The circular vernier scale reading is that graduation on the circular vernier scale that aligns with the main scale, and that is the 27th. You multiply it by the reading accuracy of the micrometer screw gauge, which is 0.01 millimeters. The value becomes 0.27 millimeters. The actual reading is the sum of the main scale reading, which is 3.50 millimeters, and the circular vernier scale reading, which is 0.27 millimeters. The actual reading, therefore, is 3.77 millimeters. The correct option is B. Example 4. Which of the following is the dimension of pressure? The options are A, ml raised to power minus 1 t raised to power minus 2. B, ml t raised to power minus 2. C, ml squared t raised to power minus 3. D, ml raised to power minus 3. Solution. Pressure is force acting normally per unit area of a surface. That is pressure equal to force divided by area. Pressure is represented by P equal to mass times acceleration over area. The dimension of mass is capital M. The dimensions of acceleration is Lt raised to power minus 2. Divide by the dimension of area, capital L squared. Then by the time you finish, you now have ml raised to power minus 1 t raised to power minus 2. Option A is correct. Example 5. What respective values of x, y, and z will the unit of force, the Newton, be dimensionally equivalent to m raised to power x, l raised to power y, and t raised to power z? Option A, x equal to minus 1, y equal to 1, z equals to 2. Option B, x equal to 1, y equal to 1, z equals to minus 2. Option C, x equal to 1, y equal to minus 1, and z equal to 2. Option D, x equal to minus 1, y equal to 1, and z equal to minus 2. The solution. Force is known to be equal to the product of mass and acceleration. Force equal to mass times acceleration. The dimension of mass is capital M. The dimension of acceleration is Lt raised to power minus 2. Thus, the dimension of force is mLt raised to power minus 2. Comparing mLt raised to power minus 2 with mx lytz. X equal to 1, y equal to 1, and z equal to minus 2. Thus, option B is the correct answer.